time, our next speaker is Brooklyn Price from Dixie State University, and she'll be talking about mathematical modeling of hair-plucking birds.
All right. Hi, my name is Brooklyn Price. I'm excited to present to you guys today. I, along with Addesyn Marshall and Abigale Goulding, created a mathematical model for hair-plucking birds. They aren't able to be here today, unfortunately, so you get to hear from me. And our coach was actually Dr. Vinod Chelamuthu, who is the person that is kind of mitigating this session. Before we really get into this presentation, I want to kind of go over some background. So everybody kind of knows what a bird's nest is. We've all seen one, and it's coming into springtime, so we're going to see a lot more birds return, and they'll be building their nests. And a lot of these nests have different materials in them, but I think we'd be surprised to learn what is in those. And in a lot of those nests, there's actually hair. And so birds in the genus Paradis have been observed snatching hair from live animals. Many birds in this genus have hair in their nest, but not all birds get hair by pulling it off of live animals. This behavior begs the following questions of what are the benefits of having hair in the nest, and what are the benefits of freshly pulling hair off of an animal over gathering hair that's already fallen off of an animal. So in order to answer these two questions, we created this schematic diagram. So this kind of shows how our birds will flow through this population. We created some differential equations that we'll go over later in this presentation, but this schematic diagram demonstrates our flow through our differential equations. So all of our birds will start out as babies, and 90% of the baby bird population dies off, so they don't make it to adulthood. And so we have them going straight, some of them going straight to the death compartment. But the baby birds that do live, they will become adult birds. And from there, they can go into one of three categories. They can either become a bird that gathers hair for their nest, a bird that plucks hair for their nest, any bird that doesn't have hair in their nest. And so it takes some time for them to build their nest, but once their nest is built, they will move into the final categories as a bird with hair in the nest or a bird with no hair in their nest. And then they'll lay eggs, and then they'll contribute to the baby bird population. So that's just kind of the general flow of our model. These are some parameters that we attained. A lot of these we got through research, and then some of them we found through just doing some estimation with confidence intervals. Some things that I think are kind of fun to note are the time that it takes to build a nest. We did some research, and it takes 14 days for birds to build a nest just from gathering hair. And it takes 7 days to build a nest for birds that are not using hair. And it takes 2 days to build a nest when you're plucking hair. So I thought that was pretty interesting, because 2 weeks, a week, and 2 days doesn't seem like a lot of time to us, but the average lifespan of a bird is around 2 years. So those 2 weeks are a lot of time for them. And then some other interesting parameters are the added risk of dying that plucking causes to the bird. We found this to be 1 out of 11, and we kind of will discuss this number a little bit later in the presentation, but that's an important one to remember. All right, here's our differential equations. As I mentioned before, they follow along with our schematic diagram. We have the baby birds, the adult birds, the birds that gather, pluck, have no hair, and then when they have their final nests. Something that you might notice is that the baby birds are only being contributed to by the birds that have nests. And this is important because birds build these nests to lay these eggs. And so when they don't have a nest, they don't have eggs to lay. And so that's why the only category that is recontributing to the baby birds is the categories that the birds have already built their nest and it's completed. All right, so in order to run our model, we had to make a couple assumptions. The first assumption that we made is that for the bird population, half the population is female and the other half is male. This is good because our model tracks the females because they're the only ones laying eggs and re-adding them into the baby bird population. Number two is 10 out of 11 times the live animal is not bothered by the bird plucking. But if a bird has a bad encounter, they have a 1 out of 11 chance for a bad encounter. And if they have that bad encounter, then they die. And it's quite interesting to watch these videos. They have a ton of them on YouTube, where you can see these birds pulling hair from live animals. They'll even pull it off of humans. And the humans will kind of shoo the bird away. But with animals, a lot of the time they don't even react. And so we got this number of 10 out of 11 and 1 out of 11 from some articles that we were reading. So that's kind of where that comes from. And then the data set that we found, we assume that it represents all of the birds in the Paridae genus. And then 90% of baby birds don't make it to adulthood is another assumption that we made. From all of the articles and information that we were gathering, we felt like 90% was a good number because they said that a majority of baby birds do not make it to be a full adult. And then we also made the assumption that the total population of birds is split evenly across 7 climates. We wanted to factor in different climates into our model. And so we just made this assumption to make things a little bit more easier for us. And then finally, our last assumption is that if a bird has hair in the nest but doesn't pluck the hair from a live animal, then they must have gathered the hair. All right, so before we talk about our results, we kind of hypothesized some possible benefits about gathering hair, plucking hair, and just in general having hair in the nest. So on the left, you can see, well, on my left, I don't know if it's on your left, but on my left, you can see the benefits of just having hair in the nest. And one of those is that they just have extra warmth and insulation from the hair. And then another is to deter predators. The scent on the hair is, we believe, is a big factor because it masks the scent of the birds. And so animals that might want to eat the birds don't smell the birds, and the birds live to be another day. And then one that we don't have on there, but we kind of briefly considered, was that the oils on the hair from the animals might also help with waterproofing the nest. And then we also considered possible benefits of plucking over gathering. And we thought, as I mentioned before, just a good way to ward off predators with fresh scent of freshly plucked hair. And then it also lowers the time spent building a nest. So the less time that they're out there gathering these materials, that means they're not out there being exposed to predators as much. Okay, so then we have the population without considering climate. So we did this first. We didn't put our climates in. We just used the number straight up in our data set. And so we have the results for population of adult birds with a nest and population of adult birds building a nest. One thing that you might notice is that the population of the birds that have nest in their hair in their nest, it grows over time. And that's because there's a larger percentage of our data set that have nest in their hair. So when we kind of divvied everything out, about 86% of the population of birds that we had data on had hair in their nest. And so that leaves, there was 2% that plucked the hair, and then that leaves the rest to have no hair in their nest. And so that's why the number's kind of low, is just because it's only a smaller percentage of the population. And then we can also see the population of adult birds building a nest, and over time that decreases because the birds build their nest and then we don't have it regenerating, so they don't need to build a second nest yet for the second year. And then we also wanted to consider death rates without considering climate, because we thought that potentially having hair in the nest with this insulation and predator protection could extend the lifespan of a bird with hair in the nest. And so we did kind of this ratio, and that's what you can see in the graph on the left. And so the birds that pluck, they kind of just shoot up really high, and then the ratio just evens off. And then if you look at the ratio of deaths of birds with a nest, so once they've got this nest complete, it's about even. And so that was kind of an interesting result. We didn't expect it to be so even, but the lines are overlapping, so you only see one line. It's because they're right on top of each other. But again, with the ratio of deaths of birds building a nest, the reason that it shoots up like that is because they have that extra added factor of death. They have that risk of getting attacked by a predator that they're picking the hair off of. So that's kind of why it shoots up and then levels off. So here's our breakdown by climate. We have 7 different climates here. And so we took our data set and we grouped it by climates. And then once we had it grouped by climates, we broke it into birds that have hair in the nest, birds that pluck hair. And so as you can see, almost all of these well, actually all of them have 50% or more of birds with hair in the nest. The lowest one we have is the tropical climate that has 57% of birds have hair in the nest. And we thought that was pretty telling because if the percentage of birds that have hair in the nest is quite a large amount, then that must mean that there must be benefits other than temperature, because why would the tropical birds have 50% of their birds with hair in the nest in the tropical climate? Birds don't really have to worry about winter as much as the whole Arctic birds do. And so then we can see in total, 86% of birds have hair in the nest and 2% pluck hair from live animals. And the only climate that has birds plucking hair from live animals is the subtropical climate. And so 100% of birds in the subtropical climate had hair in their nest, but only 20% of those birds plucked the hair. So once we broke down the climate and looked at that, we decided to find results based on two of the climates. We did the tropical climate and the subtropical climate. And we wanted to do the tropical climate just because you could compare it a little better, we thought, with how the percentage was almost around 50%, meaning almost half the birds are having hair in their nest. And so we can see right here in the top left graph, the ratio of deaths of birds building a nest. It's slightly higher for birds that do not use hair. So they're dying a little bit more, which is nice, which is good to see, because that means that there is a benefit to having hair in the nest, because the birds that gather have a lower death ratio. And then the populations of adult birds building a nest in it, once again, is just, they're going down over time just because of the bird only builds a nest once. And then you can see the ratio of deaths of birds with a nest. So they've got their nest built, and then once, this one's a little interesting because once they have the nest built, the nest with no hair actually has a higher death ratio again. And so basically, whether they're building a nest or already have their nest built, that ratio for death is a little bit higher for birds that don't use hair in the nest. So that kind of shows, hey, it's good to be a bird with hair in the nest. You get a slightly lower death ratio. And then we have the population of adult birds with a nest in the tropical climate in the bottom right corner. And that's just growing over time, as we can see. Now we have the results for the subtropical climate. We chose to do results for the subtropical climate because 100% of the birds in this climate have hair in their nest, and 20% of them pluck that hair. And we thought that would be really good because it shows that we can compare directly the percentage of birds that pluck hair to the population that gathers hair, because no other climate had birds that pluck hair into it. So it's kind of the best one for us to do, we decided. And as you can see, the ratio for the deaths of birds building a nest, the birds that pluck, it shoots up again. And that's because of their added risk of dying. They take that extra risk on when they pull hair off of a live animal. And then we have the population of adult birds that are building a nest, and that goes down over time. And the birds that pluck, that number is so low because the birds that pluck represent 2% of our total population. And so out of all of the birds that we had data on, it was only 2%. And so that kind of is a good thing to keep in mind when you're wondering, like, wow, that's such a low number. It's just because there was a low number to begin with. And then kind of the best example here would be, we have the ratio of deaths of birds with a nest. And so this kind of shows, like, is plucking better, is gathering better? In this specific climate, we can see that the nest with plucked hair seems to have a pretty consistently higher death ratio than the nest with gathered hair. And so I guess when you compare the extra life that you might get from having hair in the nest, gathering's the way to go. Okay, so after we looked at all of these graphs, we wanted to think of the possible benefits. As we mentioned before, we just thought protection from predators with the scent, and it saves the birds time to gather and pluck hair. And then it also misguides lice, which we actually thought was pretty interesting because we did a lot of research on this to find possible reasons for them to have this hair in their nest. And I guess when you have the hair in the nest, the lice choose to munch on the hair rather than munching on the bird's feathers. So that's pretty good deal for the birds because it saves them a lot of discomfort. In the future, we would like to gather data on populations that pluck outside of the Paridae genus, just to be able to compare it within genuses and see what the possible benefits could be. And then we would also like to dive into detail on the reasonings behind plucking hair over gathering. Our work showed us that it is more beneficial to have hair in the nest, but it was kind of inconclusive on whether you should pluck hair or gather hair. And so we'd kind of like to delve into which choice is better for the birds to be doing. We would like to say thank you to Dr. Chilamuthu for his help with this project, and as well for Scudum, because this presentation and this work was done as a part of the Scudum competition. And then finally, we have some sources. So I want to open it up to questions. Anyone have any questions?
Thank you, Brooklyn. Any questions for Brooklyn? Heather, you have a question?
Oh, sure. I have questions. I'm really curious, like, what is your, like, is this something that you're gonna want to really continue on? Like, are you interested in birds in general, or was it really just the process of developing the model and, you know, taking in the data?
Well, one of my partners, Addie, and I, we've worked on a couple modeling projects before, and we presented this topic because not by our choice, but we chose to be a part of the Scudum competition, and they presented to us 3 problems, and this was the problem that we felt like we could do the best work on. And so that's kind of why we went with this birds and hair plucking. But something that's kind of funny about it is after we did this work, Addie and I went on to do some more projects on birds. So I guess maybe
So
we
you
just
have-
like birds.
You have expanded from just this Scudum activity.
Yes.
Hey, Brooklyn, I have a quick question on, I know about this project. I've seen this already. So one other thing I want to ask is, this competition is just 3 weeks. How challenging is that to collect all this data and getting into literature? And what is the advice you would give to students who would like to participate?
So I had a really fun time doing this. I had a great team. And I think one thing that was really good is that we had these skills that were different from each other. So we complemented each other. But yeah, it was a little bit challenging to find some of the data that we wanted on the birds. We kept looking and looking and looking for the lifespans because we wanted to get a lifespan for each type of bird in our data set. But they just like didn't have that information out there. And so we had to come up with a way to get around that obstacle. And so we tried to do some like statistical forecasting and stuff with that to get something that would be relatively appropriate for what we wanted. So that was a little bit difficult, but I think that the 3 weeks is a good amount of time because you have the time to think about it and the time to do it. So it's long enough that you have the time to do it, but not so long that you procrastinate and don't do it. And so the advice that I would give is I would say that you should start out pretty strong that first week. And you should meet with your team and you should make sure everybody has a position or thing that they need to be doing when you're not together. And because then you're getting work done when you're together and you're getting work done apart. And so if somebody goes home and has an extra minute before they run off to do their next thing, then they can research something. And so I think just like having a strong plan for when you're together and a strong plan for when you're apart is important to success in this.
Wonderful. Thank you.
Yeah, thank you.
Can I
Let's
ask
thank Brooklyn. Oh, yes,
yeah,
go ahead, Heather.
Just one last question is, what background do you have, like, as far as classes? Like, what was it that was most helpful for you as you started tackling this?
So I have taken a couple other modeling type classes.
Mhm.
I took a differential equations course. And I've also competed in other modeling competitions. And I feel like the experiences that I got there were really applicable to this competition. My first modeling competition, I had no experience doing any modeling. I just did it because it was fun and, recommended that I try it. So I tried it and I had no experience, and that kind of like ignited an interest in it. And so I took a differential equations course. I took a scientific programming course. So I've taken a couple programming courses as well as differential equation courses. And I can't remember what the other course was called, but it was a modeling course.
That's really helpful, because I'm nervous about asking my students, because I feel like they're all just going to be overwhelmed and not want to do it. So
Yeah, I honestly think that no matter the level of comfortability you have with modeling or differential equations, you can still try it and learn something, because I tried it and I didn't really know much other than calculus the first time I did it. And it was great because I had team members who knew a little bit of something and we combined our skills. And then I really liked it. So I went out and I learned more about it. So I would say if your students want to do it, then they should do it. And they'll learn. If they don't have the skills, then they'll learn them. Like,
that's really encouraging. Thank you.
Yeah, thank you.
Most of the time I had an experience when I have a student teams, I was thinking, oh man, this is too much for them. And then they really participate and then they have fun. Just like Brooklyn, the first competition, she went with calculus background. Is that right, Brooklyn? And then after that, she rocked it. All the ICM, MCM, Scudem, everything. Like, actually what happened was, for example, they're participating in ICM, MCM next week. So they had a team last year. So that team came back this year, told me, hey, we want to do it again. Can you register our team? So they're doing it again next week. So that's how it starts, I feel like.
Yeah, I think I just need to kind of figure out how to develop a culture of that and then get people excited.
Yeah, cool.
Yeah,
thank you. So let's thank Brooklyn for the great work, great presentation. Okay, I know the conference officially ended. We have a farewell session at in 30 minutes, 6 p.m. Eastern time, on closing ceremony for that.
Thank
okay,
you.
nice to meet you here. Take care, Brooklyn.